So now we are moving to the next session, which is environmental sensing module and integration with the Unity engine. And then the goal of this session is to make a virtual curtain interactive to the airflow caused by a real fan wind. So basically, you see the virtual curtain or virtual paper are kind of fluttering based on this real wind from this physical fan. So that's what we want to do in this talk. So for that, there is a wind, and then we're going to use Arduino and the wind sensor to capture the real wind from the physical environment. And then the signal will be transferring to the Unity program through the serial communication, which is a USB cable. And then in the Unity program, we're going to use Unity cloth simulation to make the virtual curtain behavior. And then if we have time, we're going to have a server-client communication so that we can use a different platform for the user studies. And then to the this is the devices that we're going to use. So of course we need Arduino and the wind sensor. And then for this particular wind sensor, we need additional power between 9 volt and 12 volt. You can use this 9 volt battery or any type of adapter, power adapter within this voltage range. And then we'll need some electronic cables and then USB cable and the breadboard to connect this wind sensor and Arduino and through this electronic cable. For those who are not familiar with this Arduino board, Arduino is an open source electronic platform microcontroller based on easy to use hardware and software. So it can read the different input signals from the real world, like light or temperature, those kind of things, and then it can turn it into different outputs, like it can actuate different motors or the control the LED light, those kinds of things. So it actually has a bunch of different features so that a lot of people use for physical computing projects. And to use Arduino, we can use this Arduino, the developing environment IDE. So you can download this program in Arduino from Arduino website. I just download this window installer, and then while you're installing this program, you will encounter these Windows security messages, which is basically installing all the USB drivers. So you can just install all of them. And then once you installed the Arduino IDE, then you can connect the Arduino board to the PC through the USB cable, and then you can start the Arduino IDE program. So once you start the IDE program, you can choose the particular Arduino board through these tools and Arduino board. There are a bunch of different models for the Arduino board. The one that I have is Arduino Uno, and which is currently, I think, the most popular one. So you can choose Arduino board that you're using. Basically, all these boards are similar, but it has different features, and then you can choose a port, which in my case, COM port 3. But maybe your machine have different options like COM port 5, COM port 4. So in my case, when I connected the USB cable to the PC, it automatically decides which COM port this Arduino board will use. So when you go to the Windows Device Manager, so this is on your Windows. When you go to Device Manager, you will see Arduino, where the Arduino is actually connected to the PC. So this is in my case, it's a COM port 3. So Arduino has a lot of resources you can play with, and in this IDE, when you click File and Examples, you will have a bunch of different examples you can play with. So before we move on to the wind sensing part, we can just simply test some simple examples. So let's see this blink example. So you go to these examples and basics, and you can click blink, and you will see this code, blink code. So when you see this code, you will see this setup pin mode LED built-in output, which means you're gonna use the built-in LED on the Arduino board as an output. And then this loop function is basically in the Unity is an update function. So it's gonna keep going on and on. And this is a digital write LED built-in high, which is turn on the LED on the Arduino board. And then after delay 1 second, digital write LED built-in low, which is turn off the LED, and then after 1 second delay. So it's gonna keep updating this function. So once you actually build this code to the Arduino board, you can just click this verify and upload button to build this program to your own Arduino while you're connecting the Arduino to the PC using USB cable. Then you will see these kind of events happening. So as you can see here, this LED is blinking after 1 second delay. So that's just a simple example. You can easily test out if the Arduino is working fine with your PC. And then there are, like I said before, there are tons of different Arduino resources. So you can access these Arduino web page references, and there are a bunch of different YouTube clips so that you can play with this Arduino. And of course, there are a bunch of different sensors, like not only just wind sensor or LEDs, there are different sensors, so you can explore what kind of physical component you can attach to this Arduino. And then here's our wind sensor module. So I particularly like this wind sensor module because many of other wind sensors actually having this kind of fan to capture the wind in the field, in the real world. But this one is very simple, and it actually has a temperature sensor as well. This temperature sensor can actually like just calibrate the accurate wind data as well. So here it's as an ambient temperature compensation for the accurate wind signal. So you can buy this. It's $24. I'm not selling this, but I found that this is very interesting and easy to use wind sensor. So now let's connect the wind sensor with Arduino. So like I said before, Arduino has a bunch of different features like digital input output and analog input output, those kind of things. So what we're gonna use for the Arduino, the wind sensor, is this part, analog input part, and then the power and ground. So V in is the high voltage part, the ground is the low like base part. So in this wind sensor, you will see this ground, GND, ground, and 9 to 12 voltage, and output, temperature, and shutdown port. So we're going to connect this ground and voltage part and output part to this Arduino board. But like I said before, this sensor, this particular wind sensor requires a higher voltage than this Arduino can provide. Arduino basically can provide up to 9 voltage. So it needs this wind sensor requires additional power. So you can use this battery or any different power adapter in between 9 voltage and 12 voltage. So basically you can connect this ground to the minus port in this battery, and then 9 to 12 voltage to this plus part of the battery. And also you can connect this ground and V in, voltage in of the Arduino board to the battery. So this power V in port is particularly used when the device requires more than 5 voltage. So in this case, we should use this B-in port. And then finally, we can connect this 12 voltage no, output pot to this analog in port, so that basically Arduino can receive the signal from the wind sensor through this output port. But it's difficult to connect these devices directly through the electronic cable. So we use this breadboard. People call it breadboard. Interesting part is in this breadboard, these plus part on these vertical lines are basically connected. All are connected, and minus part as well. These part, red and black lines, are connected to each other like this. And the horizontal line, these ports are also connected to each other, so that you can connect one device, one of these ports, and then you can use other port to reach out to other component. So to use these breadboard and connect the Arduino and the wind sensor, we're gonna attach the power, the additional power, to these plus and minus first. So basically plus to plus part and minus to minus part. When you connect to any of these ports, like I said before, these all lines are connected to each other. And then you will attach this wind sensor, one of these parts, so that each port is connected to this line row. So in this case, this output is connected to this line, and then 9 to 12 voltage port is connected to next line, and ground is connected to the next line. And then so that you can connect this the ground to the minus voltage, whatever on this side, and plus to this 9 to 12 voltage part. So you can link these using electronic cables. And of course, Arduino is the same. V-in part will be connected to this plus part, and then ground part will be connected to this minus part. And finally, the output part is connected to this analog in. And then now it's time to download the wind sensor Arduino sketch file. So normally the manufacturer, these kind of sensor manufacturer, have these Arduino sketch file, which is the code. And then so once you're done with this, you can download the wind sensor Arduino sketch file, which is the code file that the Arduino IDE can use. And you can download it from our tutorial webpage. And the file name is Arduino sketch part, or you can actually directly download it from the manufacturer's page. So once you download it, the wind sensor Arduino sketch, you will find, when you open this code, you will find this code. So output pin is assigned as an analog 0, which we connected the output pin of the wind sensor. And then if you want to use temperature, you can assign the temperature pin to the analog 2, but we're not going to use temperature for this project. And then the serial communication is defined. The speed is 9600 baud. So basically, this is a serial communication speed. And then this loop function has it received the analog signal from the output pin from the wind sensor. And then this is a formula that the wind sensor manufacturer developed for the wind speed. And then this is a serial port print, and this is wind mile per hour signal. So the below part is for the temperature signal. So we're not going to use that. So essentially, what we're going to need is this part. Output pin is analog 0, and then serial communication is open with this speed, and then we will read this wind signal, and then we will print this wind in the serial port. So we, instead of just print, I just use the print ln, which is a new line print function, and then there's a delay like 300 millisecond delay for this printing. And then just like before, you can upload this code to the Arduino using the verify and the upload button. So this is how you're gonna do. So let me just quickly demonstrate how you will do. So once you open this WindSense, the Arduino sketch file, as I said before, you will have this output pin, Arduino analog 1, and then you can comment out. You can just remove this temperature pin, and then serial begins with this speed, and the wind will receive from this output pin, and then the wind speed will be calculated by this formula, and then you add ln over here, and then you can just remove these units, and then temperature, everything you can remove this part to this part, and then you can just change the delay 300 millisecond, and then you can click this upload directly, or you can verify first whether the code is okay or not, and then compiling sketch, done compiling, and then you can upload this. And then when you click this upload, you will see on the Arduino mode, the light will be kind of a little bit blinking, and then up here is the message done uploading. Then you will click the tools and serial monitor, then you will see this serial monitor, so you can basically see the current wind speed. So if I blow this wind, you will see the number increased and decreased back to 0 again. See? Okay, that's how it works. And then you can check whether this wind sensor is correctly working or not using this code. And then you can close this, and then you can close this. And then let's go back to the slide again. So now you open up the Unity project which you were working on before. So from here, I will reduce this slide, and then here open the Unity scene that you were working on, and then I'm gonna create an empty game object again, and then it's good to put this game object, new game object, always in the origin, and then you can name this game object fluttering curtain. And under this game object, you can create a cylinder object, and then you can name it bar. And then you can change the size like 0.7 or 0.7, and then rotate this and move this up, and then rotate this. So I'm trying to make kind of like a bar for the curtain. I think this is too big, like maybe two, something like that. And then you can move these in different positions, somewhere like over here. And then maybe you can increase length over here. we can play with it later. And then under this same fluttering curtain, you can add a 3D plane as well. So plane is like this. Then you can rotate this like minus 90 degree and move back to the bar. Maybe we can reduce the size again, just like before. So let's say this is kind of like curtain, okay. And then bar can be up over here, match to the position to the curtain. And maybe you can increase the bar a little bit more, like this. So it looks like kind of curtain. And if you want, you can add some texture for this curtain. I actually downloaded one of the curtain texture before, so you can basically update this. It doesn't look good, so you can change the direction like this. Okay, so here's a curtain, and then here, add a cloth component on the curtain. So you can add cloth component using this component and physics and cloth component. Then this component will be added to this plane. So let's change the name to curtain, and then play it and see how does it look. So when you play it, you will see the curtain will be disappearing, like falling down, because there's no fixed point for the curtain. So what we're gonna do is define the fixed part on this curtain. So click the curtain again, and then on this cloth component, you will see this button, edit cloth constraints. So when you click this, you will see this paint and 0.2, those kind of things. So when you see this curtain, you will see all these black dots. And then when you choose this number 0, which means it's a fixed point, it's not moving at all, and then you can make these but the points which is connected to the bar as a red. So you can click. There's not many things, so you can just click, or you can brush using this select or different types. You can brush things to define which part is like fixed. And then once you're done, you can hit the play again, and then this time the curtain is still there, right? Because it's fixed over there. If you can play with these different parts, like this cloth animation has different properties, so you can change this external acceleration value like 1, and then this is axis, they're kind of moving like 10, then it's moving like this. And this Y is up and down. So once you put this 0 back, the curtain will be going to the neutral position. And this Y is up and down. So if you 10, it's kind of like going 0. So you can play with this. So in this way, you can check whether this curtain is moving correctly or not. Right? So you can stop it. So now you're gonna make another new empty game object, and then we'll name it wind sensor. So through this wind sensor object, we're gonna receive all the data from the Arduino and then actually use the data for this virtual curtain. So we provide this wind sensor script before, so you can attach this wind sensor script under this wind sensor game object. Then when you open this wind sensor game object, you will see this code, which is a wind sensor class, and you will see this wind speed. Initial wind speed is 0, and it's a public variable. And then we'll have this serial port, COM3 port, which we connect the Arduino to the PC, and then the same speed that we assigned for the Arduino code as well, 9600. And then we'll use a separate thread, not the main thread of this Unity rendering, but a separate thread for receiving the data from the Arduino. And then here on the start function, we'll open the serial port, and then we'll start this thread with the serial read line function. So when we start this thread in this while function, we're gonna receive this serial read line, basically the numbers that we saw in the serial monitor windows on Arduino IDE. So we're gonna read each line, and then we're gonna parse it to float value, which is a wind speed. And then update function. Under this update function, we just for the sake of check, we just print this wind value on the Unity console window. And then once the application quit, we're gonna close and abort the thread and serial port. So that's how this code works. And then once we set this up, we can just quickly test if it works or not, and then we'll see. So play, and then you'll see 0 is increasing and just some values near 0. And then if I blow this wind sensor over here, you will see the number will be increasing over here. See, you will see this like 15 or 17. Yeah. And then if I just put it back, it's gonna go back to similar to 0, like, yeah, so 0 or something. That's how it works. So we just checked the wind sensor is correctly connected to the Arduino, and the Unity can receive the data from the Arduino. And then, but the curtain is not fluttering at all. So we can use the code that we provided for the curtain control as well. So in this curtain, we can attach this curtain control to the curtain game object. So when you see here, you will see curtain controller script, and then there's a spot for the wind sensor. You can attach this to this wind sensor part. Then let's see how the curtain control is implemented here. So curtain control class, and then in this update function, we're gonna receive the data from wind sensor wind speed. Which was a public variable in this wind sensor class. And then we'll receive the wind speed, and then if it's bigger than certain value, I just set like certain value like 1, so 1 mile per hour speed. If it's a 1 mile per hour speed, then the curtain will be moving, like curtain will be moving through, and then I'm gonna call this move curtain with this wind speed. So when you go to this wind speed function, you will see this wind direction, which is a vector 3110, which is basically the one that we play with before under the cloth simulations, the external acceleration. So you can decide which direction you're gonna make the curtain moving. So this is x1, y1, z0 direction. And then in this close component, so we're gonna call this close component, and then update this external acceleration with this direction and the wind multiplication of this direction and the wind speed, so that it can fluttering while I'm blowing the wind sensor. And then once this wind speed is lower than 1 mile per hour, I will call this stop curtain, and then put this external acceleration values 000 back to 000. That's how it works. And then let's test it out, and then let's see if the curtain is fluttering or not if I blow this wind sensor. See, that's too much, but that's how it works. So it's going to like go back to 0. Yeah. So you can adjust the level of the fluttering behavior or the wind sensor value depending on the sensitivity that you want to see. So that's how it is connected. So there are many different resources for integration of Unity and Arduino project. So these are a couple of options: RDT, Unity Asset, and Arduino. So you can easily find many other YouTube clips or tutorial for this.